Pause. Well, you're sitting, but you're still able to pay attention. It's the long start of the long week, but it's really, really exciting. It's amazing to see how much the community, the token engineering community has grown over the past year. For any of you that don't know me, I know a couple of people in the audience, but really excited to share with you what we're building with Molecule. To give you a little bit of background, my name is Kohlhaas. I've been in the Ethereum ecosystem or space since about late 2015. Worked at Consensus for just under 1.5 years on Uport, and met Simon in Cape Town in early 2016, and in late 2016 he went into like a deep rabbit hole of curation markets and meme economies. Some of that really inspired me to start thinking about how curation markets and bonding codes could be used in other industries that have big problems. So I left Consensus in June last year to build out Molecule. So what is Molecule? Molecule is an open marketplace and decentralized protocol for drug development. And I'll get into why that is a cool thing to build. So these are some numbers, standard numbers. So drug development, maybe before I jump into this, I want to really, with this presentation, kind of focus on like what is a really cool use case for token engineering and curation markets. I want to keep it short and not kind of go too deep into the technical side of it. If you're more interested in the technical side, we have lots of blog posts up on how our system is evolving, what we're focused on. Cool, anyway. So drug development was never more slow, expensive, or risky. If anyone's familiar with the drug development space, it takes about 10 years to bring a drug to market. For reference, the first iPhone came out 12 years ago. And think about how the speed of innovation in smartphones is evolving. A drug, that's how long it takes to get one drug to market from inception. So imagine you had this amazing discovery, breakthrough cancer therapeutic, it takes you ages to bring it to market. Just partially the regulatory framework, but partially the entire innovation engine that's been built around that industry. $2.5 billion to bring a drug to market. The low end is 500 million. But the high end is up to 2.5 billion. So those are like estimates from Tufts, with a 0.012 chance of success. And because of this, fewer and more expensive drugs are coming to market. So one example is a gene therapy for a pediatric illness. So for that children have from the ages of 0 to 3, and basically they don't make it after that. It's a genetic disease. And that gene therapy was launched for $2.3 million per treatment. Now it's not covered by most of the health insurances anyway. We don't cover that stuff. So this therapy was launched into the market after a long time in development, and basically 95% plus of the patient population that have that disease, will never be able to receive it, which seems really obscure if you're trying to bring medicine to market. And let's say all of that would be fine, and we could just say, cool, it's the capitalist system, it's kind of how it works. It's kind of how it is. But the internal rate of return, so the rate of return for pharma companies, has been in steady decline since the 90s. So if you look at this graph, this is the return on investment in pharma R&D. And it's projected that the internal rate of return is supposed at 0% in about 2020 to 2025. Which means economically, pharma companies would be better off cutting R&D completely, which seems even more obscure if you start thinking about these numbers. Why? Yeah.
Yeah. How does one doubt that? Isn't that because the cost of it is increasing?
Well, the cost of it is increasing, but it's because why is the cost increasing? The cost is increasing. Our thesis is because the innovation model never evolved. So pharma is operating on the same innovation model as it has since the 60s. It's an end-to-end development pipeline that is extremely closed source. So our notion, and we're happy to discuss afterwards, I'm not going to go super deep. Why? Drug development is basically like software development 30 to 40 years ago. It's driven by IP, it's extremely monopolistic, it's proprietary, everything is closed source, the industry is not collaborative. This is an IBM mainframe from the 60s, so a little bit further back. And so drug development is kind of like IBM saying today, nothing against IBM, them saying today, let's develop the next social media app. And it's going to be great. It's going to take us 8 years to bring the app to market, and it's going to cost you $2,000 a month subscription fees, but we're the only one developing social media apps because we have the monopoly, so you don't have any other choice. So that's kind of the situation that we are today. And so we started looking at this problem, and drug development is really two things. It's IP and data. You invent something, you claim intellectual property on it in the form of patents or a bundle of patents together, and then you produce a lot of data about it. It's those two fundamental things. And so the drug development process tends to go through these cycles. As the cycle goes up, your investment cost increases per cycle. So you go from discovery into preclinical phases, phase 1, phase 2, phase 3, and then commercialization. And essentially what you go through, in the beginning, you go through hundreds of thousands of potential molecular targets that can treat one specific disease area. And now each company does this by themselves, alone, whereas diseases are global and we all share the same disease patterns. So what if we had a market for this? Maybe a curation market. So instead of selecting for the virality of memes, we could now select the best potential cures in our holistic market. So essentially, that's what we're doing. The very basics of of what the technical architecture from a very high level looks like. So IP is usually based on patents or proprietary data, and IP tends to be a timestamped claim. And we said to ourselves, cool, well, it doesn't matter if we attach a CryptoKitty as a picture to an NFT, or if we attach a patent or molecular data to an NFT. So essentially what we're doing is we take information in a patent and attach it to an NFT, actually in a very similar way as TinLake operates, attaching real-life assets to NFTs as well. And then we're using a second concept called a refungible, which was first pioneered by Billy Rennekamp, which is setting the an ERC20 bonding curve as the owner address of that NFT. Very simple concept. And now what happens is you create a discovery layer for all of these different assets in an open marketplace. The second thing that happens is, so first of all, through that you can create new funding and liquidity mechanisms for IP and pricing mechanisms. IP is really hard to price in the early stages. But the other really interesting thing is that you create incentives for prediction markets. So now positive data that is released about a drug increases its price. Negative data that is released about a drug decreases the price. Very simple concept. And that solves one huge problem that you have in that industry today, is that negative data is barely released, or until it's too late, there's no incentive really to release negative data in this process. This has really interesting implications for insider trading. Like now, if anyone can kind of come in and become a shareholder in one of these markets and produce data about a specific asset, what implications does that have for insider trading? If anyone can, well, not anyone, but if it's free to produce that science. Cool. So basically, what are we doing? We're moving IP from really siloed and closed-source development pipelines into an open marketplace and R&D platform. You have a sell side on the one side bringing in IP, and you have patient, academia, investors, pharma on the other side collaborating on the development of that IP. This is something how this could look like. So this is one of our early prototypes that we built. We're trying to abstract away from crypto UX as much as we can, except for we still have a wallet in this early one. And we're introducing this really interesting concept of bounties. So you can come in as a researcher into a compound and start completing certain amounts of work, which is really interesting, specifically for very early stage assets. Cool. To keep it short, we're launching an alpha in Q4 this year. We're going to release the exact release date in I think about a week or two, still depending with our audit. So we're launching 3 pilots with early stage therapeutic research projects. One is in rare diseases, one is in longevity and biogerontology, which is kind of the science of aging research, like developing molecules that can prolong the human lifespan, potentially for hundreds of years. Very cool research. And then the third one is in psychedelic studies. The ones that I can speak about already are at the University of Toronto, and one is with the University of Copenhagen. So with Toronto, for example, it's an actual clinical trial of microdosing psilocybin and the effects of that. And for Copenhagen, it's testing super early stage molecules that will actually be that will go into a mice trial to see whether that prolongs the life of those mice. And those compounds have been screened from hundreds of different compounds, and they've selected 3. So if you buy into that market, you're actually buying into the potential future IP that comes out of these that could come out of these studies. I see you have a question. Yeah.
Yeah. So I guess you can patent psilocybin. Like, what is the input as
Yeah.
the fee for that protocol?
Good question. So, in the psilocybin case, there is no patents to be gained. On the one side, you're funding completely open source research that then belongs to the commons. On the other side, you could claim data ownership of the data that is being claimed, and the data itself is valuable because if you want to file an IND with the FDA, for example, the ownership of the data, only the owner of the data can kind of make that filing to move a potential therapeutic to the next stage, even if they don't have any IP on it.
But if the data is owned by the curve, who can make that filing legally?
So in this case, if it's still the university would make the filing. But the data could be co-owned.
Right.
So in the same way that, so with the Copenhagen use case, for example, the compound is essentially co-owned. So we chose this as a starting point specifically because it's really the first stage of drug development. So all markets are going to be on Ethereum mainnet and funded via DAI. One specific thing that is about this, the funding goals are between $40,000 to $80,000 for these projects. So it's fairly low and they can run over a long period of time. And as the funding goes in, the researchers are also going to start releasing results. So our goal is to create this incentive and feedback loop between data being released, excitement about a project happening, and more funding coming in. Cool. We've heard a lot about block science already, so I won't get into this. We've been working a lot with CAD in kind of designing an optimal setup for this. So there's different taxation scenarios that come into these curves. But if you're interested to dive deeper into CAD, we are doing an AMA with block science on the 16th of October, so sometime next week, at 6:30 CET or 12:30 UET. If you go on Block Science's Twitter, you'll find more about it. We're still kind of open sourcing questions, so please come in, put in your question if you have a question about CAD. And yeah, that was it. Wanted to keep it short. Arigato.
Any questions?
So when these pilots go live, I can participate?
Say again?
When these pilots go live, I can participate?
Yeah.
Are there any limits to people participating?
Oh, what do you mean in the actual trial?
No, I mean, I can also participate in one of the pilots.
Yeah, so all the markets are fully open on mainnet Ethereum, and there's no KYC.
No, can I?
There's no KYC, yeah.
Is there leverage?
No, there's no leverage. Okay, so I'll tell you why there's no KYC. So effectively, there is no IP yet, and there's no asset attached to the market yet. And it's not clear whether there will be one, because it could be that the study says, okay, these molecules are actually bunk, sorry. It could also be that they're like, oh wow, this is a breakthrough. This is kind of how scientific funding goes at that stage. And so they're classified as donations. You can't invest more than $5,000 just to fall under AML. But we wanted the system to be small funding amounts, testing the interaction as well as we could, and with as little friction as possible.
That's very cool.
Thanks.
Yeah, but then how do you patent it?
So if a patent is claimed, then you'd have to transfer your tokens, or either you transfer them or you get first rights to purchase into the real IP. So you can also say, well, actually, I wanted to stay anonymous and it was just a donation. You know what? I'm not gonna transfer.
And so, okay, so we have a point when we issue the patent, right?
Yeah.
And then what about the investors who are coming later and buying?
Yeah.
So you need to mint at some point new tokens,
Yeah.
right?
So I'll tell you how it's done at the moment. At the moment, at university, if they get grant funding like this, they normally have a private funder or a public funder. The private fund will often say, cool, if you get anything out of this research, I want 50%. And so then it's basically a contractual agreement between those two parties. So the university files for the IP and then says, but this IP ownership is now split between these two entities. Most likely, if there is, so with Copenhagen, we anticipate that there will be IP file. In that case, you then create a special purpose vehicle where the token holders can enter into the IP field.
How about the decisions?
Good question. Governance comes at a later stage.
Yeah, the problem with that, right, is if I'm a university, I've already thought about the governance. And
think that governance is like when it comes to IP law and IP ownership, that's you start at governance and you worry about the financing later, because this can get super messy otherwise.
And Kohlhaas was using it.
Yeah, I've had this happen to me before.
If you have if you have the setup clear beforehand, you normally want to start do financing first and then worry about the IP later. As long as the initial setup is clear.
Yeah, if I'm the scientist and I'm working like 20 years on this thing and it's my whole life,
Yeah.
trust me, governance is the first thing I'm thinking about and ownership. Even if it's through a university structure.
Yeah.
And just one opinion.
No, it's a very, very valid point. So in this case, the governance, in this alpha at least, the governance remains with the university. It's not like now as a token holder you suddenly get to have major voting rights on like what happens to this IP. It also really depends on like what the percentage is, the total percentage that token holders can own of the IP. Yeah.
Like there's a lot of contract issues for sure.
Yeah.
Especially like I've worked with clinical trial agreements before, and this is smart.
Yeah.
And if you're raising 40 grand, like the legal costs are like $15,000-$20,000 minimum. So I'm not like that's where some red flags come up, but we can talk later if you're kind of interested in some of that stuff.
Yeah. Someone has to do it.
Yes, that's a very good point.
All right.
Cool. Thank you so much, guys. And before, I want to say a massive thank you to Kazuaki for organizing the meetup tonight,
Thank you.
bringing the community together.
All right, so we have more time, so you can stay, but just make sure we have to leave by 9:30, so you can gather and hang out and have a conversation, but make sure to leave before 9:30. So thank you guys for coming tonight, and yeah. And also we have more alcohol, so make sure to grab one. And this is not America, so you can't drink in public, so make sure to grab one. Thank you.